And welcome once again. I am the database guy. So we're continuing our basic VBA coding course as we start in the basic regions of it. When we get into the intermediate, it's going to be more involved. And then advanced, I'm going to touch on some things. I don't know how much on the advanced because I don't want to overwhelm you. But we did all of this stuff right now, right? We did the if then, select case, message box, the for loops, and the for each loop. And now we're going to get into this do while, do until, and there's one more. There is, I really want to teach you that one. Yeah, the while when. And so let's look at the do while example, and I have some examples here for you. So we look at this is the first one here, our do while example. So if I'm going to type out do while, first of all, so I can show you what it does. It's going to go from 0 to 9, right? So we implicitly declare a dim. I is a long integer. And then what we do is, as long as I is less than 10, we can print it. And then what we do is we say, okay, I equals I plus 1. This is an interesting little piece of information. So our first piece of I, right, if we were to look at it, it's actually 0. We didn't set I equal to anything, if you notice. When you declare a variable, any variable, it's always going to be set equal to 0, has no value. And so we start at 0, we go to 10. So the first change after we debug print, the first calculation is that I is going to be equal to 0 plus 1, or 1. Now we go and we loop. So we go back up to the do while statement, and of course it's still less than 10. We print 1, and then 1 plus 1 is 2, and we keep going until we hit 9, which is still less than 10. But once we go from 9, and 9 plus 1 is 10, well, now it ends. It ends. Okay? So this is a do while. As long as something's less than a certain number or a condition is there, fine. You can also do a do and loop while in the same way. So let's do the do while 2, which is the next one. And we get the same output. Again, we implicitly declare I as a long variable. We just run a do. We debug print I. We make I equal to I plus 1. So again, I is 0. 0 and 1 is 1. We look at the loop while, and we're still less than 10. And here's the difference here on this one. As we move on in the sequence, when we get to 9, we print 9. I equals 9 plus 1, and suddenly 9 plus 1 is 10. 10 is no longer less than 10, and it ends the loop. Versus the one above, it will also end the loop when I is 10, or actually 9, and then your 9 plus 1 is 10. Now it's a new 10, or it's a new number of 10. It's going to end the loop before it even goes through it. But here, it sort of ends the loop just after it goes through it. So depending upon where you put that while, if you put it in the front, do while, you will end the loop before you even begin it once the condition is met. If you do a loop while, you will go through it, and once the condition is met, you will end it. So for the example of I being 9, now 9 plus 1 is 10. Now the new I is 10. Either one works pretty well. And it really depends upon where you want to run that. Do you want to run just a do or a do while? And basically, it sets a condition that is to be met. To be met. So that's our do why. And also, can you nest them? Yes, you can, but it's really, really dangerous to nest these. Because if you nest a do loop in a do loop, you are going to run the second do loop until you meet the condition, and then you're going to run the first do loop again, and you're going to meet the second do loop until you meet the condition. So I'm telling you, um, really you're going to start seeing very, very high numbers of data being processed. So if I had one do loop in there that said do the same thing it says here, and I ran that, what would happen would be I'd have over 100 pieces of information because I would be running that loop inside 10 times for every 10 times I have the major loop run. And that becomes an interesting uh, thing. So you just got to be careful with taking loops and nesting them, as I said. So now we have a do until. This is an interesting one. So what's the difference between do until and do while? Well, while is sort of sets a condition, until sets a static piece of condition that is a more specific one. So let's do the do unt first. See what we get. And we got the same thing we got with do while. Okay, so what's the big difference, you say? Um, so our do until, we declare implicitly the I value. When we do until I equals 10, we print I is now 0 for our first one, I is now I plus 1, and we keep going until we reach 10. And then we stop. So here we're going to stop before we even go through the loop. It's going to just end and stop. And this one's specific, all right? The other one was when I was less than 10, right? So not equal to 10, by the way, less than 10. If I had had equal to 10 here, I'm sorry, less than, hang on a second. Yeah, if I had less than 11, I would have gotten 10 as a value here. So, and the same thing here, if I would have looped until I is less than 11, I would have gotten 10. But here I specifically set the value for which I don't want the loop to evaluate, and that is 10. So when you look at these two, right, the do while and do until, while could run until the condition is met. Until sets a specific condition, meaning that you have a certain value you're looking for, right? And that's very different than our while, do while loop, right? And now the other one we have is do until 2, and we're probably going to get the same numbers, and we do. So what's the difference between this one? Well, very much like the do while, we can loop until. And here we implicitly declare I as a long value. We print I as 0, and then I equals 0 plus 1 is 1, and we keep running this loop until I equals 10. We loop until I equals 10. So the first one that will only do the loop when I is not equal, or when I is less than 10, to really be specific, or between 0 and 9. The second one loops until you find the value of 10. So it's going to go through it, and then once it comes to 9 plus 1, it gets to 10, it's going to stop it dead. And I think the difference really is where it stops the loop, right? The first one stops it right in the beginning. So, and the second one stops it at the end of the loop. And it's really your pleasure as to how you want to deal with that. But do until requires a specific value for which to stop, while do while just has a condition that, and you can do while again, for example, if I'm looking at record sets, I'm looking at records, do while I'm not at the end of the file. Keep running through it until I find something. Or do until I'm at the end of the file, right? As another one too. So, and that's really interesting. Now, the wend, which is while wend, is an interesting one. It's a little bit different, but we're gonna WWEND and go, and we're getting the same numbers here. We declare implicitly that I is a long variable, long integer, I'm sorry. And while I is less than 10, we'll print it. I equals I plus 1, and wend is sort of saying keep looping, right? Keep looping until the criteria is met. So what's the difference between do while and while wend? Well, I suppose it's usage of it because really you don't have to let's go back up to do while here. Let's see if I can give you the one that, yeah. So here it is. So do while I is less than 10 and then loop, right? Where here it's while I is less than 10, then when I equals I plus 1 and when. It's a different version of looping. But again, it's set for a conditional, okay? And if you want to break out of these, for example, this is where you can add, let's go up to here. So if I come in here and if I equals 7, then if I, let's see, well, say equals 7, let's say it does not equal 7, then, okay, then debug print I equals I plus 1, and end if. So if I equals less than 7, it doesn't equal 7, then you can print that. Else, I think it's end do. Let's see. We're ending the do loop, and no, not end do. Let's see. Let me just check it because in my coding database here to break out. So let's see. Yeah. Infinite loops, nested loops. We talked about some of that. Exiting loops. Here we go. That's on a 4. I'm looking at a do. Exit do. All right, not end do, but exit do. I was close. Exit do. There we go. So what we're saying here is, we're going to put this for readability here, is if I does not equal 7, any number that's not equal to 7, then go ahead, print that exit do. So let's see what happens when we run our do y. We go up to 6. Now we could have done it this way. If I equals 7, then exit do. Otherwise, we bug print. We should get the same variables as we do, same numbers, and we should do it that way. So we can exit a do loop at any time that we want. We should be careful about that, exiting a do loop. And let's see, a do until, well, same thing with the do until. We can exit that as well in the same way. It's a do loop. Going back here for a minute, let me just see. Yeah, do loops. Exit do, right? That's do until, right? And while when is strange. You have to set up an exit while when loop message or a sub, not a message, I'm sorry, a subroutine, and go to that one to exit out of it. It's tricky. Let's try it for here and see it in our example. It should work. And what is there? They set a condition? Yeah, on the if then. So if I equals 5, then we'll go that one, else. And we have to have an end if. And we'll have to over here And the reason on the while when is because you don't have the ability, let me just grab this here to this piece of code here, which is just really the statement for the subroutine. And let's debug print this, debug compile it, I'm sorry, and let's do the WWEND. And at 4, it just goes out. It does what it should do. Otherwise, you can't simply exit while. I don't think it'll work. So you have to run a goto. A goto is for a subroutine within your first one you've seen, a subroutine within a function or subroutine, right? While we're here, I'd like to go into that little page again, and of course talks about nested loops here, and we see an example here about a nested loop. I equals 1 to 10, j equals 1 to 10, and k equals 1 to 10, then c equals c plus 1, next k, next j, next I, debug c. You're going to print c 11 times. It's going to be a large one. Let's copy this and see what it does. It's going to be pretty nasty, right? And it's a public, so let's see if we can type in eggs. This is our example, 1000. So as you see here, what it does is k goes 1 to 10, j goes 1 to 10. That's 10 times 10 is 100 times I is 100 or 1000. So the final thing it prints is 1000. Now, I'm going to show you another example of really what's happening within this. We're going to put the debug in the loop. Oh boy. Whoa. And there you see it. There you see what's actually going on, right? You're seeing that's actually occurring within that loop. I'm going to put this example, nested. Really nasty. I mean, it doesn't take much. If I had 50 here, it would be 50 times 50 times 50. It's 2,500 times. It would be enormous, right? And recursion is a loop in and of itself. Recursive procedure will call itself until the base case is reached or until the stack space is exhausted, which is a nasty thing. It's going to just lock out the stack. The stack is what runs within the program, and you don't want that. And infinite loops continue to iterate, and you got to be careful because you don't want to have an infinite loop. So here, do while I equals 1. I equals 1 is always true, and stop loop. And then the other one is do until false. False is never true, stop. So these here are examples of things that it never meets the condition. It's always infinite. And when it does that, you get an infinite set of conditions. So what you want to be careful of is that your conditions can be met in your loops, that they will be met within your loops. And as you saw here, in this particular loop here, we have a for. This is a for next loop, right? We nested for next that I talked about with our for loop. I could do the do while nested as well if I wanted to. Right here, I could put another one in here, but and you see how I used the if-then condition to be able to determine where I am within a loop. And that's going to be important because when you're looping through data, you need to have some kind of condition to pick up what you're looking for, why you're looping through it, all right? And now, here's an interesting one. If I equals 7, I'm just going to comment this out, and I'm not going to run it. Then I equals 0. What's going to happen here? Well, if I does not equal 7, so it won't take the first one. It'll debug print I equals I plus 1. So I'll get 0, then I'm going to get 1. Now I is less than 10, I does not equal 7, right? Then 1 plus 1 is, I'm going to debug print I for 1. 1 is 2. I'm going to keep going until I reach 7. When I reach 7, then I will equal 0. Okay. And then I will, hang on, debug print I equals I plus I, which will be 0. We'll see the 0. And then I'm going to put this in here. I equals I plus 1. Now we go from 0 back to 0 plus 1. So I'm going to print 0 again, 0, and I'm going to keep going until I reach 7. So what's going to happen here is I'm going to go from 0 to 6. When I reach 7, I'm going to go back from 0 to 6. When I reach 7, I'm going to go back from 0 to 6. I'm going to keep looping from 0 to 6 continuously without any end. All right? It is going to exhaust the stack. So let me save, say yes. Good. I believe it's going to cause a crash in this, but we'll see if it does or if it doesn't. And as you see, it does. Let's see if the control break would work. B doesn't work. Let's see if I can stop the code. It's going to keep going. It's infinite. And you're going to start crashing the stack. And keep going and going and going, as you can see. We're going to restart the program, cancel. Yeah, you're going to have a situation here, which is really nasty, and there we are, we're back into our database, of causing it to continually go through a loop that has no end. That's an example of an infinite loop, and it will crash the stack, as you just saw, and it will make life very nasty. All right? Now, if I put the exit do back in, right? Now I won't crash the stack anymore. Once I reach the second 0 at 7, I should end it. Let's see what happens. Let's save it just to be sure. All right. And it did end it. The second one, it did end it. So once it got to the 7th one, it made I 0. It printed I. It said, okay, I equals I plus 1. Now I'm 1, but I'm going to exit do. Without the exit do there, it becomes an infinite loop. And I wanted to show you an example of that, how nasty it can be. And we'll just leave that in there like that. So the infinite loop is when you don't meet a specific condition, is when you can't meet it, and it will keep going on and on and on. Now, infinite loops can happen as well if I parse through a record set and I don't find the condition. As long as I set my loop for do until end of file or loop until end of file, I'm fine. But if I just do look for the condition and loop, then I'm going to have trouble. And you can do a do loop. So the while sets the condition. And that just is, it's interesting. It really is. So what we learned today is, indeed, we have learned the do while loop, the do until loop, and the while when. Do while means you're doing while a condition has yet to be met, or you're looking for a condition to be met. And it's not a specific condition. Something could be less than something, greater than something, could be equal to something, which is not. So if, for example, I'm looking for a value, the amount from a certain record that has to be equal to a certain value until that condition is met, I can do while that. Do until is usually more specific. Do until I meet a specific condition. You saw it, do until I equals 10, or do until RS field amount equals 24.50, $24.50. I could do that. Okay, but it's a specific amount. It's more specific. While when is sort of a quick version of the do while. We're going to take a quick look at that one, just one more last moment. but your while when, that's your nested, sorry, is more of a do while. Let's see. Right, so you set a condition, I is less than 10, and then you when to keep going until your while ends. That's what the when really is. And it loops. It's again, it's not a non-specific condition. I mean, you could say while I equals 5, right? But here's the thing. Um, you would have to be running through another loop above it, right? If I said I was doing a do loop above it, until I get to 10, do until I equals 10. And then I have my while I equals 5, do something, and then when. So, in other words, I could do that. I could set a condition in if I wanted to. But if I'm running a loop, it's while I equals less than 10. So long as I is less than 10, I can keep going through it. And you saw that. So where you use these loops, so the loops are the for loop or for each loop. That's the second one. And again, for is a more general loop. For each is when you have items in a collection or in a group of things. Do while is do while a certain condition has yet to be met, and then going back to it. So case here, do while I is less than 10, and then loop it, or do, as we saw here, do, just run the do and loop while. All right, so you can loop while. And the do is the same thing with do until a certain condition is met, or do and then until the condition is met. You can do it two different ways. And the while when is only one. And we saw, of course, exiting these loops. You need to have a for next in there to evaluate the given condition you want to exit for. And when you exit for the do's, it's simply exit do. And by the way, you can also exit on the for here. So if you're running a for loop, you can exit for. That'll work too for that loop, for the one we had previous here. You can run an exit for, and the while when, in order to get out of that loop, you're going to need that specific, and we saw this one here, you're going to need to go to a subroutine, and you can call it whatever you want. Here it's exit while when loop, and write that down here. It will go to this one. Nothing is being done underneath it except it's going to end the function in this case. So if you had done something here, right, and I said debug.print I want you to know that it actually will do something, END. Let's see, it ended on 5. So, right, so what it did is when I equals 5, it went here and it printed I, and I was 5 below here. If I didn't have this, let's run it one more time. You can see that difference. You should only get 0 to 4. And we do. So that subroutine, the only reason why it works to exit it is because nothing's in it. All right. It just goes and finishes out with the end of function. All right. So these are the loops, and I don't have any other loops I think I need to give you at this time. We're going to look at some more coding in video 7 when we get there with more statements before we hit the intermediate. It may take a few more videos, but I want to give you as much as I can as a base to build upon. So again, like and subscribe as always. I am the database guy. Wherever you are, have a great day, evening, night, or whatever. Just have a great life and take care.